Yep. So for today, if you check your Google Classroom, let me just check the Google Classroom here. Yeah, no, not this one. Right here. What? Cancel. Okay. So we have this one share. Um, this one right here. So if you check the Google Classroom, let me just put right here www Google then Classroom. Yeah, Classroom here. Mm, let's see. Oh, okay. Admit. So can you see the screen with Google Classroom, the stream? Can you see it? Here you can see the, well, let me just stop and share again. So right here. So you see the screen in the Google Classroom, right? Here is the assignment we're going to be solving here in these two line tutorials. This is the homework for this week, right? And here are two videos that explain how to obtain the sine and cosine formulas for addition, subtraction of angles. I'm not going to do this for you right now in this assignment, in this session, because, well, it's kind of boring. And it's not really very important you understand. Well, it's important you understand, but not necessarily it's critical you check how these formulas came to, right? So what I'm going to do really is take the formulas and then solve problems with them, okay? So remember, all the formulas before these ones are valid. So the Pythagorean one, the half angles of pi over 2 minus the shift, the negative angles, obviously the definitions of the functions, tangent, cotangent, secant, and cosecant, and of course, the Pythagorean secant squared minus tangent squared, cosecant minus cotangent equals 1. And these are the new ones, correct? In the videos you can check in the Google Classroom, you are going to have the way they obtain these or this. Once you obtain one of these, you can obtain the other ones, okay? Using previous identities. So the only one is, remember that you have these, right? These identities right here in your formula booklet. So everything is right here. So you keep this formula booklet next to you. Here are these ones, and the other ones I 2 pages ahead. So the Pythagorean identity is right here. And here the ones we're going to be using. Obviously, there are more for the tangent that I have not written yet. I can do that. And then these ones right here are a result of these ones here. So these two are going to give me these two right here for the tangents, and obviously these ones right here. So from these ones here, sine plus minus the angles, correct? So don't forget that those formulas are over there. These next formulas are over there by information. We are not going to use them really in this course. So we are going to finish till these identities right here. Yeah, these ones. These ones, obviously, the Pythagorean. And well, the ones we can obtain using these ones and these ones, correct? So that's it. So here the point is, we are going to use these identities to solve problems using the values in the unit circle. So remember that we have values in the unit circle, these ones, or these ones right here, that are specific values for pi over 6, pi over 4, pi over 3, pi over 2, and these ones. So, and we're going to use the formulas, these ones right here, and these values right here in the table to get values for angles that are not necessarily in these tables, but are combination of them. Let me just give you an example. For instance, it's okay. I have here in my assignment, right? I have, give me the sine. Let me just begin with degrees. It's simpler, correct? There's a, for instance, sine of 75 degrees. So I want to know sine of 75 degrees. It's okay. if I go to my table here, right? This one, I check, I don't have 75 degrees. I have 30, 45, 60, 90, 120, but not 75. So here the trick is combine these numbers. Let's suppose I work with elementary school kids. Let me just go back here, right? Yeah, let me just show you here, this one. This is what I want. So you see, I don't have 75 here. So what I want is, for instance, if I have the values 1, 2, and 3, for instance, and I want a 5, how to get a 5 if I have these numbers? This is, well, 5 is 2 plus 3. What if I need 6? Well, it's 1 plus 2 plus 3. What if I need 4? Okay, is 1 plus 3. So if you see, I combine these three numbers to get these new numbers by addition. Or for instance, if you want 1, no, for instance, 3, no, not really. Yeah, you can get values that are not in this set that you can get combining the numbers in this set. So for instance here, as you see, I have 75. It's okay. The angles I know are 0, 30, 45, 60, and 90. So those are the angles I have. How can I combine these ones to get a 75? So 75 equals what? What values you may combine?
30 and 45.
Yes, I get 30 degrees plus 45 degrees, correct? So this is, well, yeah, I don't know 75, the sign of 75, but I know the sign of 30 and I know the sign of 45. So if I use the formulas, for instance, this one, this is okay. I'm going to write it right here. This is sine of A plus B equals sine of A cosine of B plus sine of B cosine of A. So I'm going to assume that this is A and this is B, right? 30 and 45. So the sine of 75 degrees is going to be, okay, the sine of 30 times the cosine of 45 plus the sine of 45 times the cosine of 30. Everybody catch that? 30, 45, 30, 45, 30 plus 45, 75. Now, what I have to do is, okay, check my values for these angles in my formula chart, correct? I have this formula chart, yeah. So I just go here and I check, okay, technically you suppose you know them, but okay, I have here, for instance, sine of 30. Sine of 30 is 1/2, and cosine of 45 is a square root of 2 over 2. So I'm going to put here is 1/2 times a square root of 2 over 2 plus sine of 45 is, again, a square root of 2 over 2. And cosine of 30 is a square root of 3 over 2, correct? So you have these numbers, well, and these numbers can be operated. So you have, it's okay, 1/2 times 1/2 is 1/4. So I have 1/4, 1/4 here and 1/4 here. I put a common denominator. And then I have a square root of 2 plus 1 plus a square root of 3. Okay? So where is this coming from? Okay, let me just show you the details. Remember, this is basic numbers. So what I'm going to do is simply, this is okay. I have 1/2 times 1/2 is a square root of 2 over 4 plus a square root of 3 times a square root of 2 over 4. You see? Then you put the common denominator, 4. And then you have a square root of 2 plus a square root of 2, a square root of 3. And then you see that this is a common factor. Here is a 1. You see, 1 times the square root of 2. So the only thing is I factor a square root of 2, 1 plus a square root of 3, 1 plus a square root of 3. You get this one, right? So This is the value. Okay. I don't know exactly. This is the exact value. But with a calculator, I can find these values, correct? So this is what I get. Suppose now I want to solve another one. It's okay. Well, let me see. Share screen right here. So suppose I have this one. Now suppose I want 165. So I want, yeah, the sine of 165 degrees. Okay, what is that? It's okay, well, I stop share right here, and I see my formula booklet right here again. So this one, and I see it's okay. I don't see 175. I don't see 175 on this table, but I see these angles again. So 30, 45, 60, 90, 120, and all them. So the question here is very simple, right? How, yeah, how do you get the 165 combining 30, 45, 60, and 90? No way? No? 165? No way? Oh, well, let me just do simpler. 135. Let me just change 135. Yeah, 135. How do you get 135 using those values at the top? It's very simple. What you get? How do you combine these numbers to get 135?
90 and 45.
Correct. 45 plus 90 degrees. It's very simple, right? Okay, let me just now compute this thing. So sine of 135, well, let me just write the formula again. So sine A plus B equals sine A cosine B plus sine B cosine A, right? This is my formula. So I'm going to identify again A and B. So sine of A plus B, 135, is the sine of 45 times the cosine of 90 plus the sine of 90 times the cosine of 45. It's very simple, right? With this formula, I use these portions, I know, and I get my answer. So again, sine of 45 is the square root of 2 over 2. Cosine of 90 is 0. Don't forget that. Plus sine of 90 is 1. Cosine of 45 is the square root of 2 over 2. So what you have to do only is what? This is a 0, square root of 2 over 2, correct? Let me see now the one we left out. Sine of 165. That was in the problem. 165. Let me just check here again. Yes, 165. Okay, let me just go back here, right here. Okay, 165 degrees. Now remember, you can continue with 120, 135, 180, yeah? It's possible to get 165 from these values. Remember, these are the values in the table. So technically, we can use any. Right here, this one, right? You see, 30, 45, 60, 40, 120, 145, 150, okay, 150, 150, 180, right? And so on. Let's see. Stop share. Okay. Using these values, this one right here, how can you get 165?
135 and 30?
Yeah, you can use that. So this is 135 plus 30. That's correct. Is the only way?
No,
No.
no. There's
No.
45 and 120.
Uh-huh. Okay. Yeah. Okay. Well, let's work out this one, right? So it's okay. Let me just put it right here. So now it's 165. Now I'm going to put here 165 degrees is 135 plus 30 degrees or 30 plus 135. Now I'm going to use the same formula, right? Sine, sine of A cosine of B plus sine of B cosine of A, right? And well, I'm going to do my numbers. 165 degrees is sine of, I'm going to put here 30 cosine of 135 plus sine of 135 cosine of 30. Yeah. So this is A, this is B, or B or A, it's the same, right? In the addition, no problem, right? Okay, well, let's check. Sine of 30 is 1/2. Cosine of 135, remember, you can check your tables here. The 135 cosine is negative square root of 2 over 2 plus sine of 135 is square root of 2 over 2 times cosine of 30. Cosine of 30 is square root of 3 over 2, correct? Now, you multiply these numbers and then you operate them. So 2 times 2 is 4, 2 times 2 is 4. This is negative square root of 2, square root of 2. Okay. If you do the numbers, you get 4. And then you can factor a square root of 2, and then you have a negative 1 because this negative plus the square root of 3. You see? A square root of 2 times negative 1, negative square root of 2. The square root of 2 times the square root of 3 is this one right here. So here is the value. No problem. It's pretty easy, right? Well, unfortunately, there is a problem. What is the problem? That these are degrees, is fine, but you may have radians. So, for instance, the problems I skipped is 4, right? So this is, oh my God. I have radians and the radians are fractions. So I'm required to find sine of pi over 12. Oh my gosh. Now, what are the values I have? I 0, pi over 6, pi over 4. Let me just put it right here. So these are the values. I need sine of pi over 12. And what are the angles I have? 0, pi over 6, pi over 4, pi over 3, pi over 2. And over there, all the next fractions that sometimes are difficult to remember, right? So you have 2 pi over 3, 3 pi over 4, and so on. But let me just focus on this first 5, or this first 4. Pi over 6, pi over 4, pi over 3, and pi over 2. Okay, now, forget the pi, and now my question is, how can I get 1/12 from 1/6, 1/4, 1/3, and 1/2? How can I combine these numbers to get 1/12? Here is the point. Now you have to do fractions. This is, oh my gosh. What do you think? No, no idea. This is the difficult part. How do you combine these fractions? Remember, it's addition, subtraction to get 1/12. What plus minus what? No idea? Okay, let's do this trick. Yeah. So I need 12s, correct? So the first thing I have to do is make 12s here. So this is 6. 6 times 2 is 12. So these are 2 12s. Then 4 times what is 12? 3. 4 times 3 is 12. So these are 3 12s. These are 4 12s. And these are 6 12s, correct? So 2 times 6 is 12. 3 times 4 is 12. 4 times 3 is 12. And 6 times 1, 6 times 2 is 12. Okay, now this is much better. How can I combine this to get 112? No?
1/4 minus 1/6.
Yeah. So this one, I can 1/6 or these two. Check. It's very simple. If you subtract two fractions, for instance, 4 12s minus 3 12s, what you do? What you do is very simple. You put the 12, the common denominator, and then you do 4 minus 3. Okay, this is 112. Is the only way? No, because you have 3 12s minus 2 12s. This is 3 minus 2 over 12 is again 112. So here the situation is I can have several ways to get a number, right? So let's then use one of them. Which one want to use? 4 12s or 1/3 minus 1/4 or 1/4 minus 1/6. Again, let's just do the first one, right? So what I'm going to have is this one. So let me just erase all this one. So I'm going to have this, okay. This is going to be 1/3 minus 1/4 minus, correct? 1/3 minus 1/4, correct? So these are the values I'm going to use. So this is 1/12, correct? 4 12 minus 3 thirds. 3 12s is 1/3, correct? 1/12. Okay, so this is pi over 12, pi over 3, pi over 4. Okay, now I have to remember my formula, sine of a minus b. Now I'm going to use the minus, a minus b. Now remember, my formula is going to be sine a cosine b minus sine b cosine a, correct? And then the only I have to do is, okay, this is the a, this is the b, correct? So I'm going to use those angles. So it's a sine of 1/12, pi over 12, is going to be sine of pi over 3 times cosine pi over 4 minus sine pi over 4 times cosine pi over 3. So what is the secret of these problems? Not the identity. The identity is given. Is to break the angle you receive in two angles you know, values. Okay, now sine of pi over 3 is the square root of 3 over 2. Cosine of pi over 4 is a square root of 2 over 2. Sine of pi over 4 is a square root of 2 over 2. Cosine of pi over 3 is 1/2. Okay? Now, the only thing I have to do is operate those numbers and get a value, approximate a value. So again, this is 4. So my fraction is a fourth. And then I have a square root of 3, a square root of 2 minus a square root of 2. So technically this is correct, but usually in the test they ask you to factor. So you have a square root of 2, parentheses, a square root of 3 minus 1 over 4. And that's my answer. Okay? Pretty much. So this is the difficult part. Once you have your angles, right? You use your identity, then you go to your formula chart, right? Right here. You get the values from here. You plug them in, and you get that final answer. So, but this is the point. You have to imagine how to combine your fractions to get a new fraction. Okay? Questions? No? Pretty simple? Okay, let's do another example. Right here. Tangent, let me just do 5 pi over 12. Cotangent, let me see, cosine. Let me just do this one. Cosine 7 pi over 12. Okay, so I want cosine of 7 pi over 12, right? Let me just do this one, yeah. Yep, and again, my numbers are going to be the same ones, my values. So I have pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 2 pi over, and so on, correct? Now remember what was the trick. Well, the 0 really, I don't have to really use it. So this is pi over 12, 2 pi over 12. This is 3 pi over 12. Yeah, this is 4 pi over 12. This is 6 pi over 12. This is 8 pi over 12. This is 9 pi over 12, and so on, correct? So this is the trick. Remember, fractions can be added and subtracted only under the common denominator. So if you want to add, subtract this one, you have to change them into common denominator. Yeah, 2 12s, 3 12s, 4 12s, 6 12s, 8 12s, and so on. Okay, now, $1 million question. 7 12s, 7 pi over 12 is going to be what fractions? Added, subtracted, what fractions we are going to do? Well, the 12 is always the same. So this is going to be 12. This is going to be 12. And I'm going to put here yeah, this one. So it's 7 pi over 12. So it's 3 pi plus 4 pi, correct? 3 plus 4 is 7. Is the only way? No, because you can take also 9 pi over 12 minus 2 pi over 12. 9 minus 2 is 7. So you can use any of them. Now, which one do you want to use? Plus or minus? Plus or minus? Well, let's use the plus. It's going to be, yes, cosine. Cosine A times cosine B minus cosine minus sine A sine B, correct? So this is what we have. Okay, now, this is the A, this is the B, right? Right here. So I'm going to combine this one. So cosine of 7 pi over 12 is, okay, cosine of 3 pi over 12, or what is 3 pi over 12? Is pi, 3 pi over 12 is pi over 4, right? Times cosine of 4 pi over 12, 4 pi over 12 is pi over 3. So cosine pi over 3 minus sine of pi over 4 times sine pi over 3. Remember what I did? These are matched, correct? So if I, 3 pi over 2 is pi over 4. And if I use 4 pi over 3, that's pi over 3, correct? Okay, now, cosine of pi over 4, square root of 2 over 2. Cosine of pi over 3, 1/2, minus sine pi over 4, square root of 2 over 2. Sine pi over 3, square root of 3 over 2. Okay, so I do my job here with the numbers, and Well, this is going to be simply, again, pretty much the same as before. 2 times 2 is 4, that's my denominator. So I'm going to have square root of 2 minus square root of 2, square root of 3. So if you simplify or you factor is square root of 2, 1 minus square root of 3 divided by 4. Okay. Are you catching the idea now? Yeah. So if you check the homework, yep. And I don't have here the homework. Nope, I didn't load it. But in the homework, you have problems like that. You can see here pi over 12, 7 pi over 2, 5 pi over 12, 11 pi over 12, and so on. 75 degrees, 105 degrees. So you can practice this portion, right? This part right here. And well, the only you have to do is use, in case of the tangent, right? For instance, in case of the tangent, you can use the formulas for tangent. So I didn't write them here, but it's very simple. They are in your formula booklet. So you need tangent of A plus B. Yeah, you have it right here. This one, tangent A plus B and tangent A minus B, right? So it's very simple. So you can have here tangent A plus B equals tangent A plus tangent B over 1 minus tangent A tangent B. And when you have a minus, it's pretty much the same thing, except that this is going to be a minus and this a plus. So you have tangent A minus tangent B over 1 plus tangent A times tangent B, right? So those are the formulas I'm going to use, right? And remember, if you break this in tangents, right here at the values of the tangent, you see, tangent of pi over 6, pi over 4, pi over 7, all those ones are over there. So if you break in these values, you can find tangent of 105, tangent of 15, tangent pi over 12, something like that. Okay? So nothing new. With this one, you begin solving the homework. Any question? Fine.